So we're going to finish up 4.2 now. I had kind of asked you guys to try number 7 and 8 on your own, and that's where we're going to start. Let's see how we did with those two. The goal was, so that was for him to take a look at what he missed. But do you have your copy of the paper from yesterday, Christian? Okay, you can go ahead and get that up. So here, for 7, we've got this 35a plus 7, and that plus sign is what's letting us know we can't cancel anything out right now. Does that make sense to everybody? That was kind of where we ended yesterday, was that if there's a plus sign, we can't cancel out just a piece of it. I can't do anything with 35a or with the 7 because they're added together. And so what we want to do is factor something out of this. So let's try that. Find someone that's here. Or here, I'll take a volunteer for the first part. Anybody want to tell us what 35 and 7 have in common? So we're looking for multiplication. So you're on the right track. 35 is what times 5 though? 7. Right, and so when I'm asking what they have in common, I'm looking for the 7. Does that make sense? That both of those have 7? And so we can take that 7 out, make it 7 times 5a, and whenever we take the whole thing out like this, that's 7, the whole thing factored out, we're going to put a 1 in its place. So 5a plus 1. All over the 42. So now I should be able to cancel out the 7 and the 42 because the 7 is multiplied by stuff. It's not a part of any adding or subtracting. This is now one block, one piece. So the 7 and the 42. Does 7 go into 42? How many times, or what is 42 divided by 7? 6. So what we're looking at here for our final answer is 5a plus 1 divided by 6, because 7 goes into 42 6 times. So that would be our final answer. Is everybody clear that I can't add 5a and 1? Because 1 has an a and 1 does not. They are not like terms. And likewise, I can't cancel out anything like the 1 and the 6, because this 1 and the 5a are added together. So what about number 8 then? What do the top two terms have in common? This one was a little tricky because it had, you could do like some smaller numbers, but we want to get the whole thing, the biggest term that goes into all those. So, anyone have any ideas what goes into 24 and 32? Go ahead. What was that? 8. So 8 goes into 24, and some of you were wanting to say this as well, so you guys can chime in. When I factor 8 out of 24, what's left behind? 3. So we got 3. Oh, come on in. And if I factor out 8 out of 32, what's left there? 4. Now here's a little issue. What about the ends? Were there ends that I could factor out of both? Right, so we take a look here. If these both have ends, we can factor that out. So we can take that, take one n out, 8n, be left with one n here and no n's there. So 8n times 3n minus 4 divided by 16n. So now I'll keep taking volunteers for now. What can I cancel out then? So again, the stuff in the parentheses is all locked together. I can't cancel out any of that. But what about what I took out? Let's factor it out. I think that was a mistake. Okay. So, can I simplify anything with the 8n and the 16n? How do I do that? Like what do I cancel out? What's left over? One over 2, because 8 goes into 16 2 times. So you have like 1 and 2. And the n's just cancel out, right? Or reduce. n divided by n is 1. Drawing back on what you guys learned in Math 1, do you guys remember like them talking about the big one or the strategic one or like something along those lines? The idea that n over n is just 1. And so I can rewrite that as just, I'm reducing this down to just 1. 8 over 16 reduces down to 1 over 2. So I'm left with 1 times 3n minus 4 divided by 2. Come on in. Is everybody good with that one? So, what about number 9 then? Everybody turn the page over. Look at number 9. I want you to try factoring out the top and the bottom if you can. Take a look at that one. See what you can do with it. I'm going to give you 2 minutes. 2 minutes to see what you can do with number 9. It's a little bit different. A little bit different than what we were doing before, but give it a shot.
So, look at the two numbers on the top. Do they have something in common? Yeah, so take that 4 out, right on the outside. Like, yeah, and then put a... So now, put that in parentheses, and put a 4 on the outside of that. So it's 4 times, I usually put it this one. So you took the 4 out of both of those. And I'll do the same thing on the bottom. What goes into both of the terms on the bottom? So 4 doesn't go into 6. And the 6 go into 24. Yeah, so take the 6 out. And that's what I want to use. The idea is, again, you're looking at what is each have in common. So put the 4 on the outside. And then right, what's one on the inside? So put a set of parentheses. And minus 4. Right, 4 times 4 is 6. That's perfect. And then do the same thing with the bottom. We'll go 6 minus 4. That's really close. You can actually take a little bit more out. So if you take a 2, right here, this is what you want to do. You take the 4 out, you'd be left with just n minus 4. Does that make sense? You take the 4 out of both of them. You take a 6 out, there's no 6. It's just n minus 4. Does that make sense? And now I'm going to talk with you guys something.
Okay, so some of you've got it. Some of you are still working on it. Everybody take a look here. So I'm going to call some names. I've been taking volunteers, but if I call your name and you're not sure, we can work it out. So first off, I need to know, with the 4n and the 16, do they have something in common? Alina, what do you think? Is there a number that goes into 4 and 16? Yeah. So if I take 4 out of both of those, I need to know what's left inside. Kenji, when we take that 4 out, what was left inside? N minus 4. Does everybody understand what we just did there? We rewrote it, took the 4 out. 4 times n would be 4n. 4 times negative 4 would be 16. Does everybody see what we did right there? That's the same as what we've been doing. So now, we're going to do the exact same thing to the bottom. So I'm looking at the 6n and the 24. We're going to see what those have in common. So, Alondra, what goes into 6 and 24?
4.
So 4 doesn't go into 6, but it does go into 24. But we need something that goes into both. Does 6 itself go into 24?
Yeah.
Yeah, so that's what we're going to take out. Take that 6 out. And so what's left on the inside? Olivia, what would be left over if I take the 6 out of these?
And minus 6.
Real close, but it's not 6 times 6 to make 24.
4.
Yeah, there we go. N minus 4. Okay, we're building up now to the main point of this unit. So everybody's full attention right now, because this is where we may get to something slightly new. It's the same idea as what we've been doing, but we need to make sure that we understand it. 4 times n minus 4, we took a 4 out of the top. 6 times n minus 4, took a 6 out of the bottom. The 4 and the 6 reduce, right? Is everybody good with that? 4 over 6 reduces to 2 over 3. But here's the new piece. And what we're going to be doing, spending most of our time on today. N minus 4 over n minus 4. Does everybody see that this entire set of parentheses is the same? This is, yeah, the one from yesterday. So, for the n minus 4s, if the entire piece is exactly the same, I can cancel the whole thing out. One of the other teachers here calls them identical twins. You've got the exact same thing on the top and the bottom. Not just kind of the same, exactly the same. So if I have an entire parenthesis that's multiplied by other things, so 2 times n minus 4, 3 times n minus 4. The 2 and the 3, we simplify that as much as we can. But the n minus 4s, now I can't cancel out just an n or just a 4, but if I have the whole thing, n minus 4, I can cross that off. Again, this right here, that's that whole strategic one, big one. N minus 4 over n minus 4 is just 1. So that reduces down to just 1, and I'm left with just the 2 over 3. That is my final answer. So we had started to look at that yesterday. That was what number 10 was about. Was if we factor everything and I have the exact same factors, I can reduce those down to just 1. So let's try it again. Let's try 11. I'm looking at 18 and 90. I need to know what they have in common. So, Amato, can you tell me a number that goes into 18 and 90?
I'm not sure.
So are they both even?
3.
3 would work, and so would 2. Does that make sense? They're both even, but you're right that 3 works also, so 6. But maybe, is there a bigger number? So 9, let's try 9. If I take 9 out of both of these, 9, 18 divided by 9 is 2n, 90 divided by 9 is 10. Oh, but wait a second. Do 2 and 10 have something in common? Right, 2 goes into 10. I see a couple head nods. So this reduces even a little bit more. I could take that 2 out, multiply it by the 9, and really I can take 18 out of both of those.
How'd you do that?
So you can either do it piece by piece. You can say, okay, they both are divisible by 2 and by 3 and another 3 and another 2. So we had tried 9 first. 9 went into 18 and 90. Took that on the outside. But then we saw, oh, I can take out a 2 from both of those also. So we take that out. 9 times 2 is 18. And that's what's on the outside now, the greatest common factor, leaving us with that n minus 5 on the inside. So now let's do the bottom. 27n minus 54. What's something that goes into both of those? Let's get someone that's here. Jeremiah, do you see a number that would go into 27 and 54? 9. Let's try that. So if I take 9 out, 9 goes into 27 3 times, and into 54 6 times. Oh, wait a second, guys. Is there something that goes into 3 and 6?
Number.
correct? Yep, there we go. We want to be specific. So 3 goes into both of those. Take that out. So really 1 and 2, and we got that 3 out here. So right now, that's going to leave us with the top is 18 times n minus 5, and the bottom, 3 times 9, is 27 over n plus 2. Now, what goes into 18 and 27? I think they're the ones we were just going through. What's the biggest number that would go into both of those? 9. So we can reduce that. 9 goes into 18 2 times. 9 goes into 27 3 times. 2 times n minus 5 over 3 times n plus 2. So the 2 and the 3, those don't simplify anymore. Can I cancel out this 2 and this 2? Answer is no, because this plus sign, again, is connecting the n and the 2. I can't cancel out just a piece of that. The only way I can cancel out this 2 is if I'm canceling out the entire block, the n plus 2. That all has to go at once. Since it doesn't, since I don't have an n plus 2 up here, I'm going to leave this as it is. That is my final answer. Let's try another one. Number 12. Let's take a look at the top. What do they have in common? Carson, looking at the 10 and the 70, what would go into both of those? What was that? So we can probably go even bigger. Does 10 go into 70? So is everybody good? We can take 10 out of both of those. So 10 times x plus 7. Now the bottom, right here, this we're looking for how to factor it. We want two terms that multiply to 42 and add to 13. So give me some numbers that multiply up to 42. Or another way of saying that, what are some numbers that go into 42? 7 and 6 is actually going to be perfect. Caitlin got it on the first try there, because everybody, as soon as I did this, you could try 2 and 21, but 7 times 6 makes 42, and 7 plus 6 makes that 13 in the middle, right? This is what we were doing just a little while ago. We were factoring stuff like this. We're going to be factoring a lot. It's going to keep coming up. So once I see that 7 times 6 makes 42, I can factor this into x plus 7 and x plus 6. That multiplies to 42 and adds up to 13. So now, looking at this actually isn't my answer yet. I'm almost done. Do you see any identical twins? Any things that are exactly the same on the top and the bottom? Yeah, I'm seeing lots of head nods. The x plus 7s. So, as long as I cancel out the entire block, it's fine, because the x and the 7 are linked. The x plus 7 have to stay together, but if I can take out the whole thing, x plus 7 over x plus 7, that's a 1, right? It reduces down to 1. And so I'm left with just 10 over x plus 6. 10 over x plus 6. And then I cancel out the 10 and the 6, right? 2 goes into those two. I got a few of you there for a second. Can I do that? Can I do 10 and 6? Cancel those out? Why not?
Because there's an x. Right?
The x is part of it, but if it was 10 over x times 6, that would actually be fine. I cancel those 10 and 6 out. Or I can reduce them. I shouldn't say cancel. Reduce them. So that's actually what I want to talk with you about. So the parentheses are a good way of looking at those blocks, right? But it's actually not the parentheses that's keeping me from simplifying stuff, from reducing it. The reason I can't simplify the 10 and the 6 is because, again, this 6 is linked to the x with the addition, right? It's x plus 6. That stays together. You can even leave it in parentheses if you want to. If that helps you remember, don't cancel this out. Leave it in parentheses. That is my final answer. So that's my final answer right there. Let's look at 13. Same idea, but we're factoring trinomials on the top and the bottom. So here I'm looking for something that multiplies to positive 6 and adds up to negative 5. This is one that throws people off all the time because there's several ways to make 6, and we often get used to doing one or the other. How am I going to multiply to positive 6 but add up to negative 5? Any ideas? So 3 and 2, that multiplies to 6 and adds to 5. How do I make it positive 6 when I multiply, but negative 5 when I add? Any ideas?
You just minus 3
So minus 3.
plus 2. No, minus.
Yeah. So with this one, if I make it negative, is negative 3 times negative 2 positive 6? Hope so.
Yeah.
And negative 3 minus 2, does that get me the negative 5 in the middle? Okay, so we're good there. That's correct. Now the bottom, this negative right here, if you ever have a negative in front of your squared term, I would recommend that you factor that negative out right away. It tends to confuse people. If I take that negative out, that switches the signs on everything. N squared minus 10n plus 16. But let's try it now. Can I come up with two numbers that multiply to 16 but add up to negative 10? Same exact thing as we were doing on the top. What numbers multiply to make 16? 8 and 2. And again, got it in 1. Sometimes we might try 4 and 4 or 1 and 16. But those don't add up to 10, but 8 and 2 do. So those are the ones we're going to use, 8 and 2. So I'm going to factor this then. And I made a mistake on the top and nobody saw it. Normally it's not a problem, but it's about to be. What did I do wrong on the top?
You did not.
The negatives are right. A little louder. So it's actually not the positives and negatives this time, although that's a really common thing. I wrote x, which we're just so used to that. That's what we use all the time. But if I actually had x's on the top and n's on the bottom, nothing's going to cancel out. We have to be consistent. Does that make sense? So, if you can, either rewrite it, erase it, change those to n's, n minus 3, n minus 2. It actually wouldn't have been a problem if I'd done everything with x's. But since I realized that it was n's and I started writing n's on the bottom, we need to be consistent or else we're going to get stuck. But we've got now n and 8, n and 2. What are the signs for those to make it multiply to positive 16 and add up to negative 10? Plus and minus?
Yeah.
Okay, so if we do that, positive, negative, that's going to make negative 16.
Oh, we gotta make it negative.
Right, because we switched it. We took that negative out.
Both negative.
Both negative is correct. So if I write this now, I have n minus 3 times n minus 2 over negative n minus 8 n minus 2. So do we have any identical twins? Any factors that are exactly the same? You see them?
N minus 2.
Yep. N minus 2, gone. So now I have n minus 3 over negative n minus 8. Anything else I can do with that? Nope, I think we're good. That is my answer. And the last one here, top piece, we're looking for what multiplies or goes into 8 and 24. Any ideas? What goes into 8 and 24? 8 does. And again, that's a nice thing to always check. Just see, does this number go into that one? If it does, factor the whole thing out. Anything else I can take out besides the 8? The x. That's exactly right. They both have x's. So I'm going to take that x out. 8x times x minus, how many times is 8 going to 24? 3 times. All right, and then this last one, or the x squared minus 9, we've done this a ton, and it's going to keep coming up over and over again. Difference of squares, right? X squared minus, what squared makes 9? 3. So I want this x plus 3, x minus 3. So I do x plus 3, x minus 3. What can I cancel out?
X minus 3.
X minus 3's are gone. And again, I should say reduce. 8x over x plus 3. And then I just cancel out the x's, right? Wait, whoa, whoa, whoa. I see some of you going along with it.
Yeah.
What's wrong?
The plus.
So I can't reduce these because this one's still linked to the 3. Does that make sense? So that x plus 3, that's one piece. Even, again, you leave it in parentheses if that helps you. Remember that that's one block. I can't cancel out part of it. If I'm going to cancel it out, it's got to be canceled out altogether. And again, I've got to get out of that habit. We were talking about that with the other Math 3 teachers. We get in the habit of saying, like, canceling something. But really what we're doing is reducing. We're trying to say, do I have the same thing on the top and the bottom, so it would reduce to 1? I do not here. It does not reduce. So I'm going to leave this right here. That is my final answer. Now we should be done with sections 1 and 2. I realized I didn't actually collect section 1 from you guys yesterday, or I did for some of you, but some of you may not have turned it in. Make sure today, before you leave, that you turn in sections 1 and 2 if you're done with them. We have one more section that we're going to do today before we do an activity. The third section is actually identical to what we just did. It is so similar, with literally like one extra step. But it's going to look really complicated. You guys are going to be looking at these and worried. Oh man, this looks so much harder. It's not. It is the exact thing you were just doing. Let me stop the recording here.